Hello everyone. Today we will be discussing Biot Savart's law of magnetostatics. For that, let us consider a current carrying wire and we want to find out the magnetic field at a point P at a distance R from the current carrying wire. For that, we have to take into consideration a small volume, length element dl of the current carrying wire. This is the length element dl of the current carrying wire. Now, to find out the magnetic field at P, first let us find out the angle. We'll write down the theta is the angle between dl and R, which is the distance of the point P from the current carrying wire. Now, once you find out the R theta, then according to Biot Savart's law, a small magnetic field dB at point P. Because we are taking a small length here, so there will be a small magnetic field dB at point P is given by dB is proportional to I dl sin theta by r square, or dB is equal to mu 0 by 4 pi I dl sin theta by r square. We must know dB is a vector. Now moving further, dB is equal to mu 0 by 4 pi I dl sin theta by r square, where mu 0 is the permeability of free space. Now again, magnetic field produced by the entire conductor, we have taken a small length, is given by, that is the total B will be integration over the length of the conductor dB, which is L integration over L mu 0 by 4 pi I dl sin theta by r square. Now what is dl sin theta can be written as dl is a vector, r is so dl cross r cap, which shows the direction of the distance. Now, so that we can write down mu 0 by 4 pi integration over L I dl cross r by r square, dl cross r cap by r square. So this can be, this is nothing but I cross r cap by r square dl, because dl and I are in the same direction, because we know we are taking a current carrying wire. This is dl and this is I. So both are in the same direction. If there is a steady current flow, that is if I is a constant, we can take I out of the integral and we can write mu 0 by 4 pi L dl cross r cap by r square. So here we observe that B, the magnetic field, is perpendicular to the plane containing dl and r, because it is a vector product. Now, and this can be visualized using the right hand rule, that it will be perpendicular to the plane of the paper, because you are having dl in this direction, you are having r in this direction, so the magnetic field will be perpendicular to it. Now, what is the significance of this law? Why we are learning this law? Because it connects magnetic fields and currents, which are their sources, that is the source of the magnetic field. Again, it determines the magnetic field due to a current distribution. It has having a vector product. That means we are having a current distribution. We can find out its magnetic field using the Biot Savart's law. And it is similar to Coulomb's law of electrostatics. See, Biot Savart's law connects magnetic field to its sources, which are the current carrying wires. Similarly, Coulomb's law connects electric field to its sources, that are the charges. So both are similar. So that's it. Thank you.